Welcome back. In this lesson, I'm going to talk about the various different types of EC2 instances. I've described an EC2 instance before as an operating system plus an allocation of resources. Well, by selecting an instance type and size, you have granular control over what that resource configuration is. Picking appropriate resource amounts and instance capabilities can mean the difference between a well-performing system and one which causes a bad customer experience. Don't expect this lesson, though, to give you all of the answers. Understanding instance types is something which will guide your decision-making process. Given a situation, two AWS people might select two different instance types for the same implementation. The key takeaway from this lesson will be that you don't make any bad decisions and you have an awareness of the strengths and weaknesses of the different types of instances. Now, I've seen this occasionally feature on the exam in a form where you're presented with a performance problem and one answer is to change the instance type. So at a minimum with this lesson, I'd like you to be able to answer that type of question. So know, for example, whether a C-type instance is better in a certain situation than an M-type instance. That's what I want to achieve. We've got a lot to get through, so let's get started. At a really high level, when you choose an EC2 instance type, you're doing so to influence a few different things. First, logically, the raw amount of resources that you get. So that's virtual CPU, memory, local storage capacity, and the type of that storage. But beyond the raw amounts, it's also the ratios. Some type of instances give you more of one and less of the other. Instance types suited to compute applications, for instance, might give you more CPU and less memory for a given dollar spend. And instances designed for in-memory caching might be the reverse. They prioritize memory and give you lots of that for every dollar that you spend. Picking instance types and sizes, of course, influences the raw amount that you pay per minute, so you need to keep that in mind. And I'm going to demonstrate a number of tools that will help you visualize how much something's going to cost, as well as what features you get with it. So we'll look at that at the end of the lesson. The instance type also influences the amount of network bandwidth for storage and data networking capability that you get. So this is really important. When we move on to talking about Elastic Block Store, for example, that's a network-based storage product in AWS. And so for certain situations, you might provision volumes with a really high level of performance. But if you don't select an instance appropriately and pick something that doesn't provide enough storage network bandwidth, then the instance itself will be the limiting factor. So you need to make sure you're aware of the different types of performance that you'll get from the different instances. And picking an instance type also influences the architecture of the hardware that the instances run on and potentially the vendor. So you might be looking at the difference between an ARM architecture or an x86 architecture. You might be picking an instance type that provides Intel-based CPUs or AMD CPUs. Instance type selection can influence in a very nuanced and granular way exactly what hardware you get access to. And picking an appropriate type of instance also influences any additional features and capabilities that you get with that instance. And this might be things such as GPUs for graphics processing or FPGAs, which are field programmable gate arrays. And you can think of these as a special type of CPU that you can program the hardware to perform exactly how you want. So it's a super customizable piece of compute hardware. And so certain types of instances come with these additional capabilities, so might come with an allocation of GPUs or might come with a certain capacity of FPGAs, and some instance types don't come with either. You need to learn which to pick for a given type of workload. EC2 instances are grouped into 5 main categories which help you select an instance type based on a certain type of workload. But we've got 5 main categories. The first is general purpose, and this is and always should be your starting point. Instances which fall into this category are designed for your default steady state workloads. They've got fairly even resource ratios, so generally assigned in an appropriate way. So for a given type of workload, you get an appropriate appropriate amount of CPU and a certain amount of memory which matches that amount of CPU. So instances in the general purpose category should be used as your default, and you only move away from that if you've got a specific workload requirement. We've also got the compute optimized category, and instances that are in this category are designed for media processing, high performance computing, scientific modeling, gaming, machine learning, and they provide access to the latest high performance CPUs, and they generally offer a ratio where more CPU is offered than memory for a given price point. The memory optimized category is logically the inverse of this, so offering large memory allocations for a given dollar or CPU amount, and this category is ideal for applications which need to work with large in-memory datasets, maybe in-memory caching or some other specific types of database workloads. The accelerated computing category is where these additional capabilities come into play, such as dedicated GPUs for high-scale parallel processing and modeling, or the custom programmable hardware such as FPGAs. Now these are niche, but if you're in one of the situations where you need them, then you know you need them. So when you've got specific niche requirements, the instance type that you need to select is often in the accelerated computing category. Finally, there's the storage optimized category, and instances in this category generally provide large amounts of super fast local storage, either designed for high sequential transfer rates or to provide massive amounts of I/O operations per second. And this category is great for applications with serious demands on sequential and random I/O, so things like data warehousing, Elasticsearch, and certain types of analytic workloads. Now, one of the most confusing things about EC2 is the naming scheme of the instance types. This is an example of a type of EC2 instance. While it might initially look frustrating, once you understand it, it's not that difficult to understand. So while our friend Bob is a bit frustrated, he's having difficulty understanding exactly what this means, by the end of this part of the lesson, you will understand how to decode EC2 instance types. The whole thing end to end, so R5DN.8X large, this is known as the instance type. The whole thing is the instance type. If a member of your operations team asks you what instance you need or what instance type you need, if you use the full instance type, you unambiguously communicate exactly what you need. It's a mouthful to say R5DM.8X large, but it's precise, and we like precision. So when in doubt, always give the full instance type in answer to any question. The letter at the start is the instance family. Now there are lots of examples of this: the T family, the M family, the I family, and the R family. There's lots more, but each of these are designed for a specific type or types of computing. Nobody expects you to remember all of the details of all of these different families, but if you can start to try to remember the important ones, and I'll mention these as we go through the course, then it will put you in a great position in the exam if you do have any questions where you need to identify if an instance type is used appropriately or not. As we go through the course and I give demonstrations which might be using different instance families, I will be giving you an overview of their strengths and their weaknesses. The next part is the generation. So the number 5 in this case is the generation. AWS iterate often. So if you see instance type starting with R5 or C4 as two examples, the C or the R, as you now know, is the instance family, and the number is the generation. So the C4, for example, is the 4th generation of the C family of instance. That might be the current generation, but then AWS come along and replace it with the C5, which is generation 5, the 5th generation, which might bring with it better hardware and better price to performance. Generally with AWS, always select the most recent generation. It almost always provides the best price to performance option. The only real reasons not to immediately use the latest generation is if it's not available in your particular region, or if your business has fairly rigorous test processes that need to be completed before you get the approval to use a particular new type of instance. So that's the R part covered, which is the family, and the 5 part covered, which is the generation. Now across to the other side, we've got the size. So in this case, 8 8x large or 8 extra large. This is the instance size. Within a family and a generation, there are always multiple sizes of that family and generation, which determine how much memory and how much CPU the instance is allocated with. Now, there's a logical and often linear relationship between these sizes, so depending on the family and generation, the starting point can be anywhere as small as the nano. Next to the nano, there's micro, then small, then medium, large, extra large, 2 extra large, 4 extra large, 8 extra large, and so on. Now keep in mind there's often a price premium towards the higher end, so it's often better to scale systems by using a larger number of smaller instance sizes, but more on that later when we talk about high availability and scaling. Just be aware as far as this section of the course goes that for a given instance family and generation, you're able to select from multiple different sizes. Now the bit which is in the middle, this can vary. There might be no letters between the generation and size, but there's often a collection of letters which denote additional capabilities. Common examples include a lowercase a, which signifies AMD CPUs, a lowercase d, which signifies NVMe storage, a lowercase n, which signifies network optimized, a lowercase e for extra capacity, which could be RAM or storage. So these additional capabilities are not things that you need to memorize, but as you get experience using AWS, you should definitely try to mentally associate them in your mind with what extra capabilities they provide. Because time is limited in an exam, the more that you can commit to memory and know instinctively, the better you'll be. Okay, so this is the end of part 1 of this lesson. It was getting a little bit on the long side, and so I wanted to add a break. It's an opportunity just to take a rest or grab a coffee. Part 2 will be continuing immediately from the end of part 1. So go ahead, complete the video, and when you're ready, join me in part 2.